Dear students, welcome to s.mathguru classes. So our main discussion is partial derivatives. In last video, some problem discussed. Next, to consider remaining problems. The problems are very easy, very interesting, very simple. Now we consider one problem. If z equal to x plus y, z into x plus y equal to x square plus y square, show that del z del x minus del z del y whole square equal to 4 into 1 minus del z del x del z minus del z del y. This is we have to show. Now this is our condition given. From this we have to find this, but in this problem z is different, not mix up z. Z is dependent variable, x y are independent variable. Now we separate this from this. We can write z equal to x square plus y square by x plus y. We get this. Now first define del z del x, del z del x, differentiating partially with respect to x on both sides. We get this one, x square y square x plus y. We know the quotient rule, ddx of from higher secondary second year or first year. You know this is fx by gx, sometimes we write u by v, and this will be gx whole square gx ddx of fx minus fx ddx of gx. This is our formula of quotient rule or division rule. Denominator whole square, denominator ddx of numerator minus numerator ddx of denominator. Now using this quotient rule we get del z del x, this x plus y whole square x plus y del x x square plus y square minus x square plus y square del x x plus y. We get this. By quotient rule we get this one. Now denominator remains same. This is x plus y, and if we differentiate this we get twice x, and y is constant. If we differentiate we get 0. X square plus y square. If we differentiate x then 1, differentiate y partially we get 0. Then this will be x plus y whole square, and this is multiplying 2x square plus 2xy minus x square minus y square. So this equal to x plus y whole square, 2x square minus x square, this is x square plus 2xy minus y square. This is our del z del x. We consider this is number 1. This one you get. Next our requirement del z del y. In our answer given del z del y del x, del z del x, first we find this, next we find this. Next we consider del z del y, del y, and we write this one x square plus y square by x plus y, and this is denominator whole square, and this is by using quotient rule del y x square plus y square minus x square plus y square del y x plus y. This one you get, and this will be denominator whole square x plus y, and we differentiate partially with respect to y. That means x is constant. Del y of x square is 0, and del y square means twice y. This is x square plus y square, and this is 0 plus 1. We get this one. Now we have del z del y. Denominator remains same, x plus y whole square, and here we get twice y into this 2xy plus 0 is cancelled, 2y square minus x square minus y square. In front of bracket is minus sign. If we remove the bracket, all the sign will be changed, and this will be, we write here, x plus y whole square and 2y square minus y square. This will be y square plus 2xy minus x square. This is number 2 we consider. So we get del z del x is this and del z del y is this. Now taking left hand side. In our left hand side we get del z del x minus del z del y whole square. This is our left hand side. And putting the values, del z del x, we know the ready-made answer, this one, del z del x. This will be x square plus 2xy minus y square by x plus y whole square minus del z del y, this one, x plus y whole square, and this is y square plus 2xy minus x square, this whole square. This will be LCM is remain, both are same, x plus y square whole square is LCM, this is x square plus 2xy minus y square, this is minus 2xy plus x square whole square. We get this. Just remove the bracket, then this sign will be changed. Now this will be x plus y whole square, and this 2xy like terms, this will be cancelled. X square is 2x square, y square is minus 2y square, and this one whole square, and this will be x plus y whole square, and 2 common, we get x square minus y square, this whole square. And next, now this will be, denominator remains same, x plus y whole square, and this a square minus b square formula, we know this is the third formula in our life, a plus b into a minus b, 2 remains same, x plus y into x minus y, this whole square, and these two are like terms, this will be cancelled, we get x plus y, and this is 2 into x minus y whole square, and this will be x plus y whole square and 4 into x minus y whole square. We get this result from left hand side. Next we consider right hand side. In our right hand side, this is 4 into 1 minus del z del x del z del y. This is our right hand side, and 4 remains same, 1 minus del z del x. Del z del x means this value. This is x square plus 2xy minus y square by x plus y whole square minus del z del y. This is y square plus 2xy minus x square divided by x plus y whole square, this one. And if we taking LCM, LCM will be x plus y whole square, and here denominator is 1 divided this, then this will be x plus y whole square, and remove the bracket, minus x square minus 2xy plus y square minus y square minus 2xy plus x square. We get this one. If we remove the bracket, then this is minus, this one plus, we get this one. Now this 4 is remain same, denominator also remains same, but this is x plus y whole square, a plus b whole square. This is the first formula in our life. This is a square plus 2ab plus b square, and this one x square cancel, y square cancel, 2xy we get minus 4xy, we get this one. Now answer coming soon. Within a short time answer will come in our whiteboard. This is x square, this minus 2xy plus y square. X square, this minus this 2xy plus y square we get. This the denominator remains same, x plus y whole square, a square minus twice ab plus b square, this is a minus b whole square. क्या बात है! So we get left hand side and right hand side same result. In our left hand side, after calculation we get this result, 4 into x minus y whole square by x plus y whole square, and right hand side also we get, after calculation we get, this is our answer. Both the results are same, since left hand side equal to right hand side, therefore we get del z del x del z del y whole square equal to 4 into 1 minus del z del x minus del z del y. This is the proof. So short, we get this our answer, left hand side and right hand side equal. Very nice solution, very easy, very simple. Consider another masti problem. Very masti. Z equal to, if z equal to e to the power ax plus by into f of ax minus by, prove that b del z del x plus a del z del y equal to 2abz. This is we have to prove. Now solution, z equal to given e to the power ax plus by into f of ax minus by. This is number 1. We differentiate partially with respect to x, because in our answer x and del z del x del z del y given. So we differentiate partially with respect to x. We get e to the power ax plus by into f of ax minus by. We get this one. But we know the product rule from higher secondary first year or second year. This is product rule. First function ddx of second plus second function ddx of first. So some teacher written as uv and writers also written uv, u into v, u ddx of v, v ddx of u. I have written this is fx and gx. This one in our formula. First function ddx of second, second function ddx of first. So here using this formula, this is our first function, that means this is fx, and this one gx. First is fx, e to the power ax plus by. ddx of f of ax minus by plus, this is plus. Next gx means this one, f of ax minus by. ddx, del x of, not ddx, this is del x, this is partial differentiation, del x, this is del x e to the power ax plus by. We get this. This one remains same, e to the power ax plus by remains same, but this one we know ddx of fx, this is f dash x. When you get f dash x, if this x same, if x same, then we get f dash x. If it is x, then here must be x, then we get f dash x. But here ax plus by, but this one different, both should be same. If both are same, then we get this formula. So this portion must be in denominator, f of ax minus by del ax minus by into del ax minus by del x. So this is chain rule. This cancel, del x and this we get out this. And this one remains same, ax minus by, and this is also using chain rule because we know this formula, ddx of e to the power x equal to e to the power x. We know this formula. When you get this formula, if x same, then we get this formula. So this is e to the power ax plus b. This power must be in denominator here. Then we write this formula. So using chain rule, so I have written details because some students are weak in calculus. So I have written details. Then all types of student can easily understand this solution. So this is del. We get this. Now here we get e to the power ax plus by, and this same is x same. If x same, then we get f dash x, then this and this same, we can write f dash ax minus by, and a is constant, del x of x is 1, and by is constant because we differentiate partially with respect to y, this is 0, and f of ax minus by, this formula, e to the power x, then e to the power x, e to the power x dx, then e to the power x. Because power and these are same, we write e to the power x plus by. And a is constant, ddx del x of x is 1, and by constant, this is 0. Directly I have written this. And here we get ax plus by f dash ax minus by. We get this a multiplying here, e to the power ax plus by, f dash ax plus ax minus by. And here we get a f of ax minus by e to the power ax plus by. And e to the power ax plus by, e to the power ax plus by is common. Then we get a f dash ax minus by, then a f of ax minus by e to the power ax plus by. We are taking e to the power ax plus by common, we get a into this, a into this, we get this one. This is number 1 we consider. Now in our answer, so just we get del z del x, But in our answer del z del y also we have, so we differentiate partially with respect to y. Again del z del y, del y, we write this one e to the power ax plus by into f of ax minus by, this one. And this is product rule. First function del y of second plus second function del y of first ax plus by. Using this formula we get this one, and this is e to the power ax plus by. Again using chain rule, because if x same then we get f dash x. So using chain rule we get del f of ax minus by, this is del ax minus by into del ax minus by del y plus f of ax minus by del e to the power ax plus by del ax plus by into del ax plus by del y. Just using chain rule, this cancel, ultimately we get this one, and this cancel, ultimately we get this. Using chain rule we get this. Now we get del z del y. This will be e to the power ax plus by, and this is x same, we get f dash ax minus by, and we differentiate with respect to y. This is constant, then this is 0 minus b into 1. B is constant outside, del y is 1 plus f of ax minus by e to the power ax plus by, and this is 0 plus b into 1, because we differentiate partially with respect to y, means this is constant 0, b is constant outside, del y 1, and ultimately we get minus b, this is minus b e to the power ax plus by f dash ax minus by, and this is b f of ax minus by e to the power ax plus by. We get this, and if we taking common e to the power x plus by, then we get minus b f dash ax minus by plus b f of ax minus by into e to the power ax plus by common. From these two terms e to the power ax plus by common, so this is number 2 we consider. Now taking left hand side. So if we taking left hand side, we get b del z del x, a del z del y, b del z del x, we know this value, this one, this is the value, a f dash ax minus by plus a f dash ax minus by e to the power ax plus by. This value we get for del z del x, and del z del y next plus a del z del y, this is the value, just we get minus b f dash ax minus by ax minus by plus b f of ax minus by e to the power ax plus by. We get this one. So from these two terms, e to the power ax plus by, e to the power ax plus by common, and multiplying b within the bracket, we get ab f dash ax minus by, and this is ab f dash ax minus by, and this one common, and this is minus ab f dash ax minus by plus ab multiplying by ab f of ax minus by, and e to the power ax plus by is common. This, we get this one. Now these two are like terms, this will be cancelled, and we get this is ab, b is left, ab this is not f dash, this is actually f of ax minus by, f of ax minus by, yes, f of ax minus by, and this is ab f of ax minus by, ab f of ax minus by 2 times, we get 2ab f of ax minus by into e to the power ax plus by. This one we get, and this value is, this is nothing but our this one. So another line we can write ab e to the power ax plus by f of ax minus by. This one we get, and this is 2ab z. This value means we know this is z, and this is our right hand side. After a long time we get our right hand side. Therefore, what we get? Therefore, b del z del x a del z del y equal to 2ab z, and this is, you can write here using 1, using 1 also. So this is 1 I have taken 1 again here also. This is or no need to write 1, then this is, since we write this z equal to e to the power ax plus by f of ax minus by. This is our z, so in place of this we putting z, and this is our right hand side, and we have the complete proof. Hence proof. So this is the complete proof of the given problem. So dear students, these are nothing, very easy, very simple, just practice. By practice we can easily solve this type of problem. And in engineering, either it may be first semester, it may be second semester, so we have this type of problem in partial differentiation, Euler's theorem. So I shall discuss one by one. First we consider partial differentiation, next we consider Euler's theorem, and step by step we have to solve some problems. Just you are watching the video, and is there any confusion, any difficulties, then you can ask me any question, any query in comment box. So I hope you are all enjoying with this type of problem. If you are all enjoying, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.